Have you ever wondered where we might be sourcing our minerals in the future? Could it be from the infinite depths of space? The concept of asteroid mining, once a fanciful notion relegated to the realm of science fiction, is becoming an increasingly plausible reality. You see, asteroids, those hurtling space rocks that orbit our sun, are not just celestial bodies, they're potential treasure troves. And the race to tap into these untapped resources has begun. Space agencies from Japan and the United States have recently launched missions to investigate and even retrieve samples from asteroids, nudging us closer to the day when we might extract precious minerals from them. But it's not just government agencies that are interested. Private companies like AstroForge, Astronautica Corporation, and Karman are all gearing up to test their space mining technologies. They're investing, innovating, and pushing the boundaries of what we thought possible. And the reason is simple. Asteroids could be rich in critical metals used in electronics, solar and wind power, and electric car components, particularly batteries. Imagine, instead of the controversial and potentially harmful practice of scooping cobalt, nickel, and platinum from the seafloor, we could be extracting these minerals from asteroids where there's no risk of harming wildlife. And the potential scale of this industry is staggering. Studies suggest that in the next several decades, the production of some metals from space could overtake their production on Earth. But it's not just about bringing these resources back to our planet. In the future, robots might mine these minerals in space, using them to construct spacecraft or habitats for astronauts. This would radically transform our approach to space exploration and colonization. So, the idea of mining asteroids is not just a figment of our imagination anymore, but a potential reality. As we stand on the cusp of this new era, we can't help but wonder, what does the future of mining look like? And how will it shape our world, and perhaps even other worlds in the years to come? But what does it mean to mine an asteroid? And more importantly, is it economically viable? To answer these questions, we need to delve into the economics of asteroid mining. Asteroids, these hurtling space rocks, have the potential to be the gold mines of the future. They are rich in critical metals like cobalt, nickel, and platinum, which are essential components in electronics, solar and wind power, and electric car batteries. The demand for these metals is soaring. Electric vehicles, for instance, need about 6 times the minerals that conventional cars do, requiring both nickel and cobalt in significant quantities. Solar panels also need nickel, while wind turbines need cobalt. The International Energy Agency predicts that by 2050, the demand for cobalt could rise 6-fold, reaching 1 million tons per year, while the demand for nickel could quadruple. At the same time, the cost of reaching these asteroids is decreasing. Thanks to reusable rockets developed by companies like SpaceX and Rocket Lab, the cost of launching payloads into space has plummeted by a factor of 20 per kilogram since 2005, and it could decrease even further. But the real game changer could be the potential for significant returns. It's difficult to put a price on an asteroid, but we can estimate their worth based on the value of the metals they contain. For instance, cobalt currently sells for around $33,000 per ton and nickel for $20,000 per ton. A recent study by Ian Lange of the Colorado School of Mines, co-authored with a researcher at the International Monetary Fund, even suggests that in 30 to 40 years, the production of some metals from space could surpass their production on Earth. According to their calculations, metallic asteroids could contain over 1,000 times as much nickel as the Earth's crust, in terms of grams per metric ton. So, is asteroid mining economically viable? Given the current trends in demand for critical metals, the decrease in space launch prices, and the potential for significant returns, it seems asteroid mining might not just be feasible, but potentially profitable. But what could this mean for our planet? Could asteroid mining help us alleviate some of the environmental and social issues associated with terrestrial mining? Let's delve into the potential benefits of asteroid mining for Earth. First off, it's no secret that mining on Earth can be a dirty business, causing significant environmental damage. It disrupts landscapes, contaminates water supplies, and contributes to air pollution. But asteroid mining, conducted millions of miles away in the vacuum of space, could sidestep these issues entirely. We could extract valuable resources without harming our planet's delicate ecosystems. Furthermore, mining operations on Earth often occur in regions grappling with political instability and socio-economic challenges. This can lead to exploitation and human rights abuses. Asteroid mining, on the other hand, doesn't involve any communities being displaced or workers risking their lives in unsafe conditions. It's a high-tech endeavor conducted by robots under the control of engineers safely stationed on Earth or in orbit. But the benefits don't stop there. The materials mined from asteroids could also be used directly in space. Imagine building spacecraft or habitats for astronauts with materials already in space. This could significantly reduce the need for launching materials from Earth, a process that is not only costly but also energy-intensive and carbon-emitting. In essence, asteroid mining could lead to a new era of space manufacturing and construction. It could enable us to build and maintain a permanent presence in space, all while easing the strain on Earth's resources. It's a win-win situation. And let's not forget, these extraterrestrial resources are not just limited to metals. Some asteroids also contain water, which could be used to support life in space or be broken down into hydrogen and oxygen, the components of rocket fuel. This could potentially create refueling stations in space, extending the range of our space missions. Asteroid mining could potentially revolutionize not just our approach to resource acquisition, but also our relationship with our own planet. The possibilities are as vast as the universe itself. It's a future that's exciting, sustainable, and full of promise for both our planet and our ventures into the cosmos. So, what does the future hold for asteroid mining? As we gaze into the crystal ball of possibilities, the future of asteroid mining appears to be more than just a sci-fi dream. The growth of the space mining industry has been as relentless as the asteroids themselves, spurred by the burgeoning demand for critical metals used in electronics, renewable energy, and electric cars. But let's be clear, this is not an easy ride. The journey to mine these celestial bodies is fraught with challenges. Technical hurdles need to be overcome, regulatory frameworks need to be established, and of course, the costs associated with space travel need to be reduced. However, companies like AstroForge, Astronautica Corporation, and Karman are not shying away. They are preparing to test their tech in space, paving the way for asteroid mining. A study by Ian Lange of the Colorado School of Mines suggests that within the next 30 to 40 years, we could see the production of some metals from space overtaking their production on Earth. That's right, asteroids could become our new mining sites. According to Lange's study, metallic asteroids could contain more than 1,000 times as much nickel as the Earth's crust. Not to mention significant concentrations of cobalt, iron, platinum, and other metals. Thanks to the reusable rockets developed by SpaceX, Rocket Lab, and other companies, the cost of launching payloads into space has plummeted since 2005, and it could drop further. This makes the prospect of asteroid mining even more feasible. In the future, robots could be mining these minerals for use in space, building spacecraft or habitats for astronauts. And while there are certainly challenges to overcome, such as refining methods that depend on gravity, the potential rewards are great. Imagine if we could bring these resources back to Earth, where there is an ever-growing demand for them. The value of asteroids has not yet been quantified, but the critical metals they contain are reappraised by markets every day. As we stand on the brink of this exciting new frontier, the potential of asteroid mining is truly astronomical.